Iron, while abundant in Earth's crust, does not naturally occur in forms that are usable to humans. The earliest recorded iron artifacts can be traced back to the 3rd millennium BCE Egypt, where iron beads have been found in burial sites. In contrast to later iron tools, these early artifacts are made from a distinct iron-nickel alloy, meteoric iron. Since meteorites entering the atmosphere did not go through the oxidizing process, the iron inside these meteorites can be readily used to make various tools and artifacts. These tools are much better and easier to make compared to their bronze counterparts due to the fact that bronze production requires both copper and tin, the latter being incredibly rare in the antiquity. However, meteoric iron was and is incredibly rare. I mean, it's not like you want to summon more meteorites from the sky. So, people tried for millennia to create furnaces hot enough to reduce iron oxide into elemental iron.
The first result of these efforts was the brewery. Brewery furnace works in a similar principle compared to modern blast furnace. The temperature produced inside a brewery is still not hot enough to completely melt iron. Instead, it produces a porous mixture of slag and iron called broom. Hence the name brewery. Broom can then be reheated and beaten with a hammer to drive out all slag, leaving behind a low carbon iron alloy referred to as wrought iron. The brewery was not producing enough iron for the increasing demand of iron tools and weapons across the world.
Introducing the blast furnace.
Is for separating impure elements from the extracted hematite and reducing the pure substance from the ore. The origin of blast furnace dated back to Han, China, 200 BC, where the original model was created. In 1709, British inventor Abraham Darby advanced this process by implementing charcoal as a source of coke, which further industrialized that process.
Hematite mostly contains Fe2O3, but only 60% of the hematite is actually pure iron that we can use for making steel or whatnot. The other 40% will consist of oxygen and other impurities, such as sand. Therefore, additional materials are required to be added to the blast furnace in order to extract pure iron. Such materials are coke, which can be used from charcoal, hot air, and limestone.
The hot air in the blast furnace ranges from 550 degrees Celsius to 850 degrees Celsius, which causes the blast furnace to range from 250 degrees Celsius at the bottom to 1500 degrees Celsius on the top.
The reactions in the furnace occur with these respective steps. First, hot air is blasted into the furnace, preferably at the bottom of the furnace, in order to provide enough heat for the process. Hot air is used to react with coke in order to produce carbon dioxide. So this is the equation for the burning of coke. This reaction is an exothermic reaction, therefore heat is also produced. This will keep the temperature of the blast furnace consistent, which make this range of the blast furnace to be 1500 degrees Celsius. Then carbon dioxide reacts with solid coke, charcoal, to produce carbon monoxide, which is then used to react with iron ore to extract pure iron. And this range of temperature is from 1200 degrees Celsius to 1300 degrees Celsius. The carbon monoxide that is just produced is now used to reduce iron dioxide and form pure molten iron that sinks to the bottom of the furnace. And here's the reaction. 3CO plus Fe2O3. These reactants will produce 2Fe plus 3CO2. At this range of the blast furnace, the temperature will be 700 degrees to 850 degrees Celsius. Even though this is considered the main reaction of the blast furnace in order to extract iron, there is also an alternative reaction that can be used to use up the excess coke. This is a reaction. 2Fe2O3 plus 3 carbon to produce 4Fe plus 3 CO2. As you can see, this reaction is really efficient because it produces 4Fe comparing to the original reaction that produces only 2Fe. Therefore, the blast furnace, considering using charcoal and coke, which can be associated as not as good to the environment, it is actually very efficient and can limit the usage of resources. Hot waste air exits the blast furnace through these directions. And remember when I said that we had to include limestone as one of the material that is added to the blast furnace? Now here's how the limestone is used. Limestone is called CaCO3, and by using the heat produced from the blast furnace, it is decomposed into CaO plus CO2. Calcium oxide is then reacted with silicon dioxide, which is one of the impurity in the hematite, in order to produce calcium silicate. And here, calcium silicate is called slag, and it can be used as a building material. Because the density of the slag is very light, it will float to the top of the product's container of the blast furnace, while the molten iron will sink to the bottom. And that's how they can extract these different products at different levels of the blast furnace.
Inside this pot right here, we have a mixture of aluminum powder and iron oxide called thermite. If supplied with enough activation energy, the iron oxide should react with the aluminum powder to create iron and aluminum oxide in a double replacement reaction. To supply this activation energy, we use a thermite igniting stick. Having the proper amount of activation energy, the double replacement reaction occurs, creating molten iron hot enough to melt the clay pot.
This informative video is sponsored by Gravity Cleaner, which helps every teachers to clean up their lessons.